Module 5, Lesson 7, we're going to look at distance on the coordinate plane again. And we have a table asking us to determine the lengths of the given line segments by determining the distance between the two end points. So we'll need to slide back and forth, but our first line segment is line segment AB. And on the coordinate plane, remember, we just need to, first of all, locate. We can just count, that's true. But let's take a look at calculating it from the coordinates rather than just counting. This is our origin right here where the x and y axis meet. So the ordered pair for A would be -2. Remember, we're going to the left from the origin. -2, and then 1, 2, 3, 4, 5, 6, 7, 8. -2, +8. And then our coordinate for B, remember this is our origin, so we count over 1, 2, 3, 4, 5, 6, 7, 8, 9, and it is also 8 up because it's the same distance up as A is. So 9, 8 is our ordered pair. The distance between the two we can determine numerically, even if I know that many of you will go down and count. -2 is 2 units away from 0 to the left. So the absolute value is how far it is, 2 units, and then another 9 units to the right of 0. So altogether they are 11 units apart. And we prove that by showing the absolute value of -2 plus the absolute value of 9 equals 11. Now let's look at line segment BC. Line segment BC. The first endpoint, which is C, is same distance over as B, which is 9 units, and then 2 units up. So C was 9, 2, and B was 9, 8. I'm going to put the points, as you should in the order that they appear in the naming of the line segment, this first column, because we'll be able to talk about them better when we do that. Please notice the x coordinates are the same. If both coordinates are different, we really have a problem that is a little beyond what we're doing right now. But since those coordinates are the same, the distance between them, we have +8 and +2. So they're both on the same side of 0, and we would have to subtract them to find their distance, which is 6. And so what we have again is the absolute value of 8 minus the absolute value of 2. And we're subtracting them because they are on the same side of 0. CD, again, the point C was 9, 2. And then D was 9 and 1, 2, 3, 4, 5 in the negative direction. So 9, -5. And the distance between them would be 7. And because they are on opposite sides of 0, one is positive, one is negative, we'll add their absolute values. So we have the absolute value of 2 plus the absolute value of 5, and that is 7. BD. Now point B, the ordered pair was 9, 8. We know that because we located it up here and here. And D we located in our last problem, which was 9, negative 5. And the distance between them then, notice the x-coordinates are the same, and they are opposite sides of 0. This is positive, this is negative. So we'll need to add their absolute values together to get the distance between them. And our proof, again, is the absolute value of 8 plus the absolute value of negative 5 equals 13. DE. D, remember, is 9, negative 5. We've been working with that for the past 2 examples. And E, we need to locate. Here's 0, and we go 2 in the negative direction, and then 1, 2, 3, 4, 5 in the negative direction. So E is negative 2, negative 5. The distance between them. Now notice, now our y values are the same, negative 5 and negative 5. And the x values are the ones that change. This is positive, this one is negative, so we'll need to add their absolute values, which will be 11, and we'll prove that showing the absolute value of 9 plus the absolute value of negative 2 equals 11. Please make sure that on your packet you go down and count as well so you can see that that is true. Next we have EF. The ordered pair for E is negative 2, negative 5. And the absolute, let's see, the ordered pair for F, which is new for us, this is 0 again, so 1, 2 in the negative direction, 1, 2 in the negative direction for our y value. So F is negative 2, negative 2. And again, our x values are the same, so our y values are the ones that we're looking for the distance from. And they are both negative. So if they're both negative, we're going to find the difference between their absolute values, which is 3. And we'll prove it here. The absolute value of negative 5 minus the absolute value of negative 2 equals 3. And we're subtracting them because they are on the same side of 0. Next, we have FG. F, remember, is negative 2, negative 2. And G, we have to locate. It is, here's 0, so we're going 2 in the negative direction, and then 1, 2, 3, 4, 5, 6 in the positive direction for our y value. Negative 2, 6. And for the distance, again, our x values are the same. Our y values are negative 2 and positive 6. So they're opposite, which means we will have to add them together. And that will give us give us a distance of 8. And our proof then would be the absolute value of negative 2 plus the absolute value of 6 equals 8. Okay, next we have EG. E was the ordered pair negative 2, negative 5. And G was the absolute value negative 2, negative 6, or positive 6. The distance between the two, EG, would be negative 5, positive 6. So we have to add their absolute values together, which would be 11. And our proof, the absolute value of negative 5 plus the absolute value of 6 equals 11. Next we go to GA. The ordered pair for G is negative 2, 6. The ordered pair for A, I'm going to slide up here, was negative 2, 8. All right, and the distance between the two, the x values are the same and our y values are both positive. So we will subtract to get the distance between the two. And our proof would be the absolute value of 6. Oh, actually, we have to take the larger number here. We're going to have to subtract the smaller number from the larger number. So the absolute value of 8 minus the absolute value of 6 equals 2. So they're 2 units away from each other. We have FA, and F is -2, 2, and A is -2, 8. And the distance between the two, again, the x values are the same, and our y values are both positive. So 8 minus 2 is 6 units. And we'll prove that. Absolute value of 8 minus the absolute value of 2 equals 6 units. And our last point is EA. E is -2, -5. And A is -2, 8. The distance between the two, our x values are the same, our y values have opposite signs. So we'll add them together, the absolute values, and get 13. And our proof would be the absolute value of -5 plus the absolute value of 8 equals 13. And there we have it. When you look at the table and the diagram, the distances between those points should make lots of sense to you, and you certainly can count them to find them as well. In the exercises, you have another table and another diagram that you're going to complete in the same way that we did in the example. So I will give you the full feedback of the table, but make sure that you can locate each of those, find the distance, and write the proof in the same way that we did in the example. And here we have the completed table that goes along with your drawing. Again, make sure that you can name the points with the correct ordered pairs, and you find the distance, of course, by adding if they are on opposite sides of 0 and subtracting if they are on the same sides of 0.